Hello, my name's Alan Dempsey and I'm the project manager for Print City, Manchester Metropolitan University's 3D printing facility. We led Work Package 2, Polymer 3D printing, on the WIP project. As part of Work Package 4, Skills and Training, we developed a series of short videos presenting different parts of the 3D printing process. In the third session, I'll provide an overview of the 3D modeling software, what to consider when selecting the software, and how and where to get training. I'll finish this session off with a short case study of how we use 3D modeling software for Work Package 2. So 3D modeling software, I'll refer to it from now on as computer-aided design or CAD package. And there are a variety of CAD packages available to design parts for 3D printing. So each CAD package comes with its own pros and cons, which is based on cost, capabilities, the ease of use, and some provide enhanced features. It's important to note that some organizations already own licenses for 3D design software or CAD packages. You should check within your own organization if you already have CAD package licenses before you procure any new ones or get any training on CAD software. It's important to procure the right license for your organization, and also you should check what the rules are, what you're allowed to do with each CAD package for your organization and for what you intend to use that software for. So there are loads of different CAD packages on the market. It'd be possible to list them all here. So I've listed a few down with the software providers down the left hand side and the CAD packages next to each one. So Autodesk make a few. The first is Fusion 360. That is a CAD package that we use at Print City very often and also across the university. But Autodesk also make Inventor, Tinkercad, 3ds Max and AutoCAD. Next we have Dassault Systems. They produce a piece of software called SolidWorks, which is heavily used in industry, as well as CATIA. There are Blender and Rhino 3D CAD packages, and finally Siemens make a couple, so they make Siemens NX and Solid Edge, to name but a few. I think that once you've identified and selected a CAD package that's right for your organization and for what you intend to use it for, it's quite simple to go and find registered training providers where you're able to go and get accredited training on that particular CAD package. So I'm going to show you what we used CAD package for now through a case study, which was the river water monitoring basin. So this was a device that we developed in collaboration with United Utilities and a company called Badger Meter in the Northwest. Essentially, it's a device that holds an arrangement of sensors beside a river to test river water quality by pulling water through a trough, and sensors take readings of the quality of that water. So you can see kind of the workflow here, left to right. We started with a workshop where we sketched out what the system needed to look like and where it could be optimized. We took that feedback and turned that into a CAD model, which I will show you now. Unfortunately, the sound's not working, so I'll try my best to talk over it. So you can see here we've got the model of the sensors. They're imported into Fusion 360. The sensors are then arranged so they're level and compact. From here, a sketch is drawn around the sensors. And this sketch is then used to form the sensor arrangement plate, the top piece. The same sketch is then extruded below to create the basin, which is the orange part on the left. And then inside the basin, a fillet tool is used to create a curved bottom to create a bowl. We're then able to add screw threads through the arrangement plates and the basin. finally, we're able to produce holes for pipe fittings and existing plumbing. So you can see here is the CAD model, here is the first prototype, and here is a cross-section analysis of the sensors, the arrangement plate, and the basin. So some features in this this water basin include we were able to put in a curved bottom, so that was intentional. That was to reduce the buildup of suspended solids as the water flowed into this system, potentially affecting some of the readings. We were able to reduce the volume of the basin down to 1.1 litres. We're thinking about a smaller volume of water needing to be pumped, meaning a smaller pump could be used, requiring less energy through the system. Finally, I'll just skip back a slide. Between version 1, lab testing, and feedback, in version 2, we were able to add a hole for an existing pipe fitting, a tap essentially at the bottom. And the idea here is that the operations and maintenance team who'll be visiting this system would quickly be able to open that tap on the bottom and flush the entire system out, removing any buildup of suspended solids. So we're quickly able to go from sketch to CAD model to prototype 1, which was tested in the lab, to finally a prototype 2, which had those enhanced design features, that tap connector on the bottom, relatively quickly. The final point to note is that we intentionally had the trough and the arrangement plate as two separate parts. We thought that in the future, there may be a different arrangement of sensors or a different make and model of sensors selected. So the idea is that arrangement plate is only a small amount of material, and if you did change the sensors, you wouldn't need to change the entire system, just the arrangement plate to complement that particular arrangement of sensors. So with that, I would like to thank you for your time, and hopefully you can tune in to future sessions. Thank you.